have a special announcement by Infinity Aerospace, the creators of ArduLab, an open source platform for the International Space Station. And if we could get Manu and Brian up for the special media announcement. There they are.
Check. Check. You guys hear me? Excellent. Welcome. Good morning. Thanks for joining us for our media announcement. My name is Brian. I'm here with Manu in the back. He'll be driving a little bit. We're the creators of ArduLab and the founders of Infinity Aerospace. For the past 2 years, it's been our mission to enable the space community at large to easily do research and experimentation on board the International Space Station. And over those 2 years, we've created some tools that make that a reality, and we want to share that with you today. We're going to start with ArduLab. Some of you may have heard of it, but ArduLab is an Arduino-powered hardware platform for autonomously conducting experiments on board the International Space Station. We've taken the basic Arduino and worked with NASA and NanoRacks to modify it with features that make it compatible with the International Space Station. And then we've taken all of that technology and we've enclosed it inside of a flight-ready aluminum chassis. But to explain this, let's take a look at a real-world example. Shit. An 8th grade class in Houston, Texas had a question. Could they optimize the plant growth in microgravity on board the International Space Station using different wavelengths of light? Without an ArduLab, this 8th grade class would be stuck with designing and building all of the hardware that goes along with sending something to space. Luckily, this particular class had some NASA funding, and we sent them an ArduLab. On the left-hand side, you can see the ArduLab as it's built and delivered to them. In the middle, this 8th grade class has begun to design and build their experiment inside that ArduLab. They've partitioned the ArduLab volume into 2 sections for 2 different plant experiments. They've installed some low-cost open-source cameras to track their progress and capture that plant growth. And they've begun to connect all of those electronic pieces of their experiment to the ArduLab computer that you can see down there at the bottom. On the right-hand side is a fully functioning space experiment. That's an experiment that is ready to fly and operate autonomously on board the International Space Station. And that's one of its tests. You can see some of the plants growing there. Now, this is an 8th grade class that's built an autonomous space experiment. But the most impressive thing is that this class built this experiment in 6 months. And this is what the ArduLab can do. But what enables the ArduLab to do this? What enables such rapid experiment development and deployment? It starts with the ArduLab's computer. The ArduLab's computer is Arduino-based, but it has the capabilities of a mass storage device too. So it satisfies all the data requirements of your typical experiment, but it can also communicate with the ISS computers and eventually down to Earth and to these experimenters and to these 8th graders. Enclosing the experiment and the ArduLab computer is our modular aluminum flight-ready chassis that's been carefully designed with the easiest mounting points inside so you can quickly install all of your experiment hardware and get it up and running fast. The combined ArduLab computer and flight-ready chassis take up only 10% of the volume you're allowed to go up to the space station, leaving 90% for your experiment or this 8th grade class's experiment. So who really uses ArduLab today and in the past? Well, you'll probably recognize some of these logos. These are companies and organizations that have put their faith into the Argilab technology and have created and conducted space experiments with the Argilab. These experiments include plant and yeast growth, adhesive studies, protein formation, and microfluidics. Now, for the past 2 years, it's been our mission to engage the community at large. And previously, this technology has been somewhat limited based on your funding. But today, I'm very proud to announce that the Argilab is now completely open source. Everything from the hardware to the electronics, it's downloadable by a click of a button on our brand new website that we're launching right after this conference. Here's a snapshot of one of the pages from our website. This is my favorite page because on this page, with one click, you can download all of the engineering drawings and 3D models to build your own Argilab yourself, as well as the electronics to have it assembled and the software that goes along with it. But to give you guys the full experience, I'd like to take you to the website, and we'll take a tour. So we've got a little bit of a squish here, but this is it. This is what we're launching. And the website goes beyond just allowing you to access those Argilab engineering and so forth, the Argilab product itself, and downloading all of the engineering technology. The website is built to guide you through the steps that will take you from an idea to an experiment operating autonomously on board the International Space Station. And the first step is to understand what the heck you're doing. So we talk about the ISS, we talk about the hardware a little bit, and this is designed to show anybody what it means to go to the ISS, what you're dealing with, and what the Argilab is fundamentally. The next step is to actually create your own Argilab. If you're a university student, you can download right there, download plans, walk into your machine shop, hand that to the foreman, and your Argilab can be built in a matter of hours. All of the tutorials are online that we've previously included or previously provided to our customers. Get your Argilab up and running from the first time you plug it in, and all of the features that are included in the Argilab as well. Once you've got your Argilab built and everything's up and running and looking good, it's time to actually install your experiment. And we'll show you examples of how you can install it. You saw that example earlier today there. But we have other examples that you can see what it means, what it looks like, what does success look like, and so forth. Once you've got it installed, you want to test it because this thing has to run for a certain amount of time on board the International Space Station without anybody touching it. Next, you would integrate your payload, send it off to NanoRacks. They will send it up to the ISS for you, and it gets launched. So we're really excited about this, and thank you very much.
Thank you, Brian. And if you have any more questions, Brian will be in the back and outside to accept any media questions.